Hi, my name is Sarah Powell, and I'm at the University of Texas at Austin. And today in this STAIR Tailored, we're going to focus on how we can solve one-step equations that have a subtraction operator symbol, and we're going to use a tool called the algebra tiles. Now, the algebra tiles can help us solve problems just like these. And if you're interested in purchasing some of these algebra tiles, you can follow this link. You can also usually just look in your internet search engine and type in algebra tiles, and it will likely come up for you. But we're going to use the algebra tiles to solve x minus 3 equals 2 and 5 equals x minus 2. And I say that these are one-step equations with a subtraction operator symbol because in both of these equations I see the minus sign. So let's go ahead and get started. Now, as we're solving these equations, it's important to have them written out for students. So I've just written mine on a sticky note here. You might write yours on a whiteboard or whatever other resources you have. And we're going to use the algebra tiles. Algebra tiles look like this. I'll go ahead and bring in just a few so we can talk about them first. Algebra tiles have rods, and there's a green side and a red side. The green side represents positive x and a positive variable. We're going to use x today. And the red side represents negative x, or your negative variable. And then these units have a brown side and a red side, as you can see. And the brown side will represent a positive 1, and the red side will represent negative 1. So I'm going to scoot those to the side as we set up this first equation. So here we have x, and that's a positive x. Now I need to take away positive 3. We don't have positive 3 to subtract, so I can use 0 pairs to get to the point where I have positive 3 to subtract. So I bring in one 0 pair, still don't have positive 3 to subtract. I bring in another 0 pair, still don't have positive 3 to subtract. And I bring in a third 0 pair. And now we're to the point, yay, where I can 1, 2, 3, I can subtract those positive 3. Now on the other side of the equal sign, we have 2, and that's a positive 2. So I'll bring in my 2 brown units just like that. Now in algebra, we want to isolate the variable. And we do that by removing this constant. To get this constant to equal 0, we use 0 pairs. Man, we use those 0 pairs a lot, don't we? I'm going to create 3 0 pairs on this side of the equal sign so that this equals 0. But whatever we do to one side of the equal sign, we also have to do to the other side of the equal sign. So I'll bring in 3 positive units because I just did that here and I want to do that there. Now let's go ahead and remove our 0 pairs. I could create 3 of them. And so here I can see that x equals 5. And if I plug that back in, 5 minus 3 does equal 2. Now let's solve this next problem just a little bit more quickly. We're going to start with 5, and that's positive 5. So I'll go ahead and bring in 5 units just like that. And that equals x minus 2. And why does this happen? Look at our last problem where we solved those and we brought in the 0 pairs to end up subtracting positive 2. Then you end up with basically these 2 negative constants to show the equation. So I want to isolate this variable. We do that by removing the constant. I'm going to bring in 2 positive units on that side of the equal sign to create 2 0 pairs. But whatever I do to one side of the equal sign, we also have to do to the other. Now I'm going to go ahead and remove my 0 pairs, and I can see that x equals 7. And if I plug that back into my equation, 5 does equal 7 minus 2. So we did a great job solving both of those problems. And I hope that you'll look at some of our other STAIR tailored sessions where we see how to use algebra blocks and how to use cups and counters to solve these same types of problems.